Hello everyone, I'm Mohammed Arefin. I'm a PhD candidate from Computer Science and Engineering Department of Mississippi State University. Here, I'm going to present our paper named Effects of a Distracting Background and Focal Switching Distance in an Augmented Reality System. The authors of this paper are Mohammed Arefin, Nate Phillips, Alexander Plopski, and J. Edward Swan. In this presentation, at first I will start with the problem statement, then I will talk about the previous work, and after that I'll briefly describe our experiment, and I'll finally talk about our experimental results and the discussion. Most of the currently available optical see-through AR displays have a fixed focal distance which ranges from 1.25 meter to the 2.5 meter, which brings the issue of focal distance switching. Focal distance switching means accommodating between two focal distances to see information with a sharp focus. From the focal distance switching, we get the focal switching distance, which is the absolute difference between the previous focal distance and the new focal distance. Now, if you look at these pictures are taken from a YouTube video where a person is wearing a Google Glass and walking in an urban street. What we observe from this video is that when the person focuses background, his foreground air information becomes blurred, and when the person focused on the foreground air information, his background becomes blurred. Therefore, to integrate information, this person needs to switch his eye focus back and forth every time between the two focal distances. Another important issue is the real-world background effect. We know that real world is very complex and dynamic. It has different type of objects of different color, different shapes. Also, the objects can appear at any distances from the user. We don't have also any control on the real world environment, and the lighting condition also highly fluctuated. Therefore, it is very important to consider the real world background effect while designing the AR interface. In 2018, Gavert, Meyer, and Swan investigated the AR display context switching and focal distance switching on human performance using a microvision nomad AR display and with a text-based visual search task. They found a significant negative impact of context switching and focal distance switching on human performance and eye fatigue. However, this research have some certain limitations, and one of the major concern is that their experimental findings may be related to their experimental display. Therefore, in 2020, Arefin and his colleagues replicated the text-based visual search task on a very different AR display on AR haploscope. And they've generalized the issue of focal distance switching in an AI user interface design. So in the pictures, you can see that participants wearing two different type of displays, and both experiments are totally different and done in two different conditions. However, if you look at the graph or the results, they have the similar type of finding. What they found is that due to the focal distance switching, participants more likely to miss the target letters when it appears on the first line of the text. Therefore, we can say that previous research has found a significant negative impact of focal distance switching on eye fatigue and human performance. However, these results are based on a solid background and no distracting features were considered. Furthermore, in 2007, Gavard and his colleagues investigated the effect of text drawing styles and background on human performance using the same text-based visual search task. They have found the evidence that background, text drawing style, text color have a significant impact on user performance. However, they didn't consider the focal switching distance in their experiment. Therefore, we can say that no previous work examined the effects of both focal distance switching and complex background together in the experiment. Altogether, we have set up our research goal. Our research goal is to systematically investigate the effect of a distracting background and focal switching distance in an optical see-through augmented reality system. We set up our hypothesis. We have two hypotheses. The first hypothesis is that, consistent with the previous work, increasing focal switching distance reduces task performance and increases eye fatigue. Our second hypothesis is that a distracting background further reduces performance and increases the eye fatigue. To explore our research question and to test this hypothesis, we have considered AR haploscope as our experimental display. AR haploscope is very powerful and dynamic display because it has the capability to dynamically change the accommodation and verdance demand. Also, this display can be adjusted for a wide range of IPDs. We have adapted the text-based visual search task from Gavin and Swan, and in here each task has 5 subtasks and 25-second time pressure was provided. So in this presentation I'm just showing you one single subtask here. Participants were instructed to focus on the right text at first and find out the target letter. Target letter is a side-by-side identical letter. For example, here the target letter is O because the small o and capital O is side by side. And then the participants were instructed to focus on the left text and count how many times it appears on the left text. Here the answer is 1. And after getting the number, participants were instructed to use a numeric keypad to provide their answer. So let's talk about our experimental variables, which is starting with the independent variables. So we have the focal switching distance, which was our continuous independent variable. We have real text distance at three levels, 0.67, 2, and 4 meters, and we similar for the air text distance. As I mentioned previously, that focal switching distance is basically the absolute difference between the previous focal distance and present focal distance. Therefore, we have the focal switching distance was either 0, 1.332, or 3.33 meter. We have another independent variables, which is the categorical independent variables background. We have two types of background, blank and the distracting. During the blank condition, subjects will observe the textual information on a solid black background. This is basically our control condition. In a distracting condition, a complicated urban scene background was considered and participants observe the textual information on that background. And if you look at that, you can see the different composed of building, text and sign and different distracting elements are on the background. We have measured how many subtasks are completed by the participants and how many of them are correct. We also gathered the eye fatigue information from the subjects by using a 7-point bipolar rating scale, where 1 means very low fatigue and 7 means very high fatigue. This is our overall experimental setup. Here you can see that subjects are looking through the AR haploscope for the AR text, and the real text was presented on a physical monitor. So we can move the monitor at any of the 3 different distance levels, and AR text can be presented at any of the 3 distance levels. In our experiment, we have considered 8 participants with both normal and corrective vision, and age range from 24 to 54. We have considered within subject experimental design, and all the experimental variables are properly counterbalanced. Therefore, each subject observed 90 tasks. Note that each task has 5 subtasks. Let's talk about our analysis and results. To analyze our results, we have considered the multiple regression method described by Perhauser. We considered 3 steps to determine whether a linear model that best fits the data or not. At first, we tested the slope test, which indicates the slopes of the tested linear fits significantly differ or not. If the slope test is significant, then we haven't done any other testing. If the slope test is not significant, then we test the intercept test. If the intercept test is significant, then the 2 fits with a common slope are reported as the best overall description of the data. If the intercept test is not significant, then we use a simple regression for describing the overall description of the data in the experiment. We also reported the effect size of R square and dr square, where R square is the overall percentage of variation explained by the linear model, and dr square is the percentage of variation explained by the categorical variable. Now let's look at our results. Start with the task performance. Here is the table and the graph for our task performance result. Let's look at the graph at first. Here the x-axis showing the different focal switching distance amount in meter, and y-axis showing the number of subtasks. We have 2 panels, one for the completed, another for the correct. You can see 4 different colors here for 4 different level of the focal switching distance, and the shape is basically indicating the background blank or distracting. and the table is defining, showing their F values here. So you can see in our graph that we are just reporting a single linear regression line here because we haven't found the significant slope different, significant interface different. Therefore, we are just reporting here the simple regression equation here. So we can say that we did not observe an effect of a background on performance in this case. However, if you look at the linear regression line, you can see that as the amount of focal switching distance increased, number of softwares completed decreased, and as well as the accuracy also decreased. Let's look at the eye fatigue. Here, similar to the previous graph, you can see that there's only a single linear equations are here because we didn't observe any slope difference and intercept difference significantly. Therefore, there is no interaction effect, no effect from the categorical variables, and only the main effect of focal switching distance exists. Therefore, we can say that we did not observe the effect of a background on eye fatigue. However, we can see that as the amount of focal switching distance increased, participant eye fatigue is also increased. So, the results of our experiment support our hypothesis 1. Therefore, increasing focal switching distance reduces task performance and increases eye fatigue. However, the results do not support the hypothesis 2. A distracting background further does not reduce performance and increase eye fatigue. There could be two possibilities. One is there is no such effect. Other is the effect was too small to be detected by our sample size, which is one of the main limitations of our study because we have considered only just 8 participants, and which brings the idea of our future work. In a future study, a larger sample size can be considered to investigate this background and focal switching distance effect together. Also, in our experiment, we have considered a single complicated distracting background, but in future, in other study, a sample of different examples of background could be considered for investigating this problem. And binocular eye tracker could be integrated in the experiment to track the participants' perceptual depth changes during the experiment. That's all from my part, and if you have any questions, I'll be happy to answer that.